Okay, so we have a scenario where a customer's complained about low voltage shutdowns on a machine. You go up to it, you run the machine up, and you find that the voltages are all of a low voltage and it shuts down, which is about 40-50 volts per phase. This would indicate straight away the alternator is quite healthy. The voltages across the phases are balanced. There is an indication of a healthy alternator there straight away. So what we're looking at straight away is to carry out a series of checks to find out what the problem is. Okay, so what we're going to do here now, we're going to test the excitation field for resistance, and this should be reading about 10 to 15 ohms as per fault finding guide. So if we pull the blue and yellow off now, test. So 10.7 ohms, so we know the excitation field is okay. Put those two back on. Obviously make note of the terminal positions when you remove the wires. So the red one, the third one along, and the other one. So these two red wires here will be your auxiliary winding inside the alternator, and they should read about 1 to 2 ohms, okay? So we know that's healthy as well. So those two items there can affect the output of the alternator and give the same scenario of residual voltage as displayed. So we know those two test okay. So we know we're possibly looking at an issue with either the AVR or the rectifier pack at the back of the alternator. So this is placing the flashing wires into the excitation field wiring, which is the blue and yellow, which plug into the AVR. What we're going to do here now is test the excitation to prove it's not the AVR that is fault. So having this button here is basically flashing voltage into the exciter to see if it comes up to near enough nominal voltage. So we'll start the generator up. So as we can see there now, the voltage failed to come up near enough to nominal. So this points out the problem to be with the rectifier, the diodes at the back of the alternator. So normally if you had an AVR issue, the voltage would come up to nominal and it would prove that the AVR is at fault, okay?
So we've got the multimeter set for diode testing. You could use continuity, but you don't get an accurate reading. And again, in ohms, the readings can be misleading. So if you stick with the diode test facility, we've got a known faulty diode pack and a known good diode pack. We'll do the good diode pack first, identified as the negative diode and the positive diode. And we're going to check each in both directions. So on the good one, make sure we have a good connection. And we get 485 ohms in one direction. Swap the direction round. Open circuit. So that diode is functioning correctly. Now the positive diode, make sure we have a good connection on the probes. 497 ohms in one direction and open circuit in the other. So that diode pack is working correctly. Now with the known faulty diode pack, continuity or closed circuit in one direction, and we should be reading an ohms resistance value there, and we weren't, it was just continuity. And same in the other direction, so we know that positive diode has failed. And we're getting the same results for the negative diode, continuity with no resistance in both directions. So we have a faulty and a good diode pack.
Okay, so what we're going to demonstrate now that the diodes have been tested and proven to have failed. So what we're going to do now is we've replaced them, and now we're going to press the button to flash the excitation field to see if the voltage comes back up. And this will prove that it was the problem and the AVR can be reintroduced into the system. Okay, so what we see there is the voltage is now coming up to nominal voltage. Depending on the size of the alternator, 9-volt battery will only sort of bring it up so far, but on a small machine like the 45, it's sufficient to bring it up to nominal voltage. A 12-volt battery is normally recommended to do this, but it can't be used as the same cranking battery on the alternator. You have to have a separate battery to carry out this test. Okay. And then removing, pressing back. So what we're going to demonstrate now, we've plugged the AVR back in. We're going to run the machine up and see if it comes back up to nominal. If it does not come back up to nominal, then we need to have a look at the AVR. So we now see that the alternator is fixed and we don't need an AVR. Brief recap on a test that we've done so far with AVR fault finding. So we know the excitation works okay, but we're still not getting anything when the AVR is plugged in. So there's a possible chance that the AVR is at fault. What we're going to do here is replace the AVR, show you how to set it up. And this is for a non-synchronizing machine because there's a slightly different setup when it's a synchronizing machine. So right now we're going to disconnect the AVR, remove it, swap it for a new one, replace it, set it back up again and run it up and put it back to nominal voltage. So what we're doing now, we're removing the wiring. It's always best to take a picture or make a note of all the wire locations before you make any component removal. Take the nuts away. Okay, remove the AVR, replace with a new one. This being the new AVR now, they are pretty much all set up from factory. They usually come with silicon across the other 3 potentiometers, meaning do not disturb them or anything like that. The only pot that you should adjust is the voltage pot, which is this one here. We have matched the potentiometer from the old AVR to the new one to eliminate the amount of time we need to adjust it on the machine when it's running. So with the new AVR, we're going to replace it into its system location. Screw the nuts back on. Okay, what we're doing now is replacing the wiring. Okay, what we're going to do now is set up the AVR with the generator running. As I mentioned, setting it up from the old AVR is a good way of getting it as close to nominal voltage by looking at the old potentiometer on the old AVR and matching it with the new AVR. So that will eliminate the amount of time you're spending inside the enclosure to adjust it. The other way of doing it, if you never removed the AVR and it was a previous engineer and there was no AVR on there and it's straight from the box, you've put it into the machine, you can set it up on the machine. The first thing I would actually say to you before you do this kind of thing is take the timers for the undervoltage alarms, put a delay on them through the editor of the front screen of the deep sea controller, increase the time on it so it doesn't shut down prematurely while you're trying to adjust it. So what we're going to do now is go into the editor, go to generator, go to the undervoltage delay alarm, increase it to about 30 seconds, which give you more than enough time to adjust the voltage. Yeah, so by adjusting, as I'm demonstrating, I've already set it at 30 seconds. So by doing this, as I'm doing now, take it back up to 30 seconds. Okay, you press and hold the tick button, which will take you back out and save the settings back into the controller. So now when we run the machine up, it will not shut down for 30 seconds on undervoltage warnings and shutdowns. Okay, so what we're going to do now is run the generator up, adjust the voltage by using the front of the panel, and then stop the machine once everything is set back to nominal voltage. What we'll do after that then is go back into the editor and readjust the delay timer down to 0, just so the protections are back on again. So the next step is to adjust the potentiometer to the position that we require for the voltages. By doing this, you need a multimeter or using the display of the controller to get the correct voltage. Okay, now that we've adjusted the voltages, we can go back into the configuration and reset the delay timer for undervoltages. So the next step of this is to run it back up again, make sure everything's okay with the frequency, the voltages, everything like that, and then the machine is ready to go.